Geometry section 12.5, circles in the coordinate plane, or what I would simply say is the equation of a circle. And starting here in with notes, the equation of a circle with center h comma k, now that's an ordered pair with numbers, so like 3 comma negative 2 or 0 comma 0, whatever, and radius r, that's a number as well, is given by this equation, x minus h squared plus y minus k squared equals r squared. Now the first thing I must say is that, I even explained it up here, is that h, k, and r are numbers. X and y are variables. So when you're writing the equation of a circle, there should always be present an x and a y as they are. Don't convert them to numbers. If you're asked for an equation of a circle, it's x, and then it's plus or minus something in parentheses squared, plus y, the variable y, plus or minus, so whatever it is. And the natural form of this is negative, but if h itself is also negative, you'd have minus negative, which we should turn to positive. I think we'll see that happen in the examples. Another common mistake, just to watch out for, is make sure that your r gets squared, okay? That's not just the right side of the equation is just r, no, it's r squared. And vice versa as well. If we have a number over there, let's say it's 81, well then the radius is 9, right? Because 9 squared is 81, okay? And this is standard form. I'm not aware of any other forms of circles, but they probably do exist, so they do call this standard form for the equation of a circle. Now here's a question. What does this remind you of? Something here squared plus something else squared equals a third thing squared. Something squared plus something squared equals something else squared. What does that remind you of? It should remind you of the Pythagorean theorem, a squared plus b squared equals c squared. Let me give you a quick explanation as to why that is. This is, in fact, the Pythagorean theorem. That's where this comes from. Okay, let's just suppose that you wanted to find the distance from this point here to this point here. Okay, what you could do is then set yourself up a Pythagorean theorem problem, right? So you want to find this length here. You could set yourself up a right triangle situation like this. It's not going to snap perfectly there, but you know what I'm trying to do. And there, and you could do a squared plus b squared equals c squared. Well, the difference from here to here, if I called this point here h comma k, and this point right here x comma y, and being one of the infinitely many points that'll be on the edge of our circle, I'm going to draw that in just a second, stay tuned, you would be doing the difference between these two x points. That would be x minus h. You see that? X minus h. The difference between these two, which would be y minus k, that's here, those are distances, those are lengths on the triangle. And that length, which on my drawing here is 2, so 2 squared plus 4 squared would be equal to, if we call this r, that's the radius of the circle. Okay, so when we collect all of those points, all of those x comma y ordered pairs, because I could have really put it anywhere, but what I'm talking about is having a constant radius. Whatever the radius is, it would be the same thing. You would end up getting this circle. Okay, so again, x and y are variables because they can change, and the entire collection of them in any particular circle with a certain center and a certain radius, the entire collection of them is the circle itself. So you might say this, the edge of the circle, or maybe you say the circumference of the circle. That's not really correct, but you know what I'm trying to say. Okay? Now, a couple of examples. Not that one yet. It says, write the standard equation of a circle with center -8, 0, and radius the square root of 5. Okay, I'm not crazy about that, so I'm going to change the 0 to 3. Okay, and I'll come back to the 0 in just a second. Let's just say it's -8, 3, and then the radius of the square root of 5. I'm going to change that too. Let's say it's just a radius of 5. We'll come back to their example in just a second and do it too. We know that the equation of a circle is x minus h squared plus y minus k squared equals r squared. That would be then, for the example that I just adjusted to make more to my liking, would be x minus -8. We've talked about this many times. When you have minus negative, you should change that to plus. Don't leave it as minus negative. Please change it to plus. X minus -8 in parentheses squared plus y minus 3 in parentheses squared. The 3 goes in for k, that negative 8 went in for h, and the radius being 5 would mean 5 squared. Here's another thing with simplifying. Don't leave it as 5 squared. Please do square that. That's not a difficult math situation at all, and call it 25. Okay. So again, for the problem that I just adjusted this to, a center of negative 8 comma 3 and a radius of 5, this equation right here would be the equation to the circle with that information. Now let's just back it off and go with theirs. You can, 0 is a number, the 0 is the y value. I'll just roll to their answer here. So they're going to plug that 0 in here for k, this negative 8 in here for h, and the square root of 5 is getting plugged into r. Now think about what's going to happen when the square root of 5 gets squared. It's going to be just 5. So their answer is going to be x plus 8 squared plus y, and you can include the minus 0 if you want to, so y minus 0 in parentheses squared equals 5. And in their final answer, they did take the minus 0 out. Obviously, y minus 0 is just y, so there really is no need to show the minus 0, and for that matter, then the parentheses. Okay? Next question. It says, write the standard equation of a circle with center 5, 8 that passes through the point negative 15, negative 13. Okay, so notice that this problem is similar to the first one, but that they didn't give us a radius, rather they gave us a point on the circle. So here's what will happen. This equation of a circle, let's just plug 5, 8 in for h comma k, would be x minus 5 in parentheses squared plus y minus 8 in parentheses squared equals r squared. And if you were all here, I would open it up to the class as to how we're going to figure out this r squared. And what inevitably comes up when I ask that question is someone will say, let's use the distance formula. And that's absolutely one way you could do it. You could do the distance formula, find the distance between 5, 8 and negative 15, negative 13. The distance formula was back in chapter 1, and you could find out that length. That length is the radius. You square it, and you have your equation. You have what's missing in your equation. Okay. Now, there's a better way, I believe, and I think a little bit more efficient, and that is to plug these points in, or these coordinates in. So plug negative 15 in for x. And I know somebody might be thinking, well, you told us at the beginning not to do that, that there needs to be an x and a y present. That's correct, and there will be in my final answer. I'm only doing this temporarily to solve for r, and then I'm going to put x and y back in. So basically, my final answer will be what I have right here already, except I will have figured out what r squared is. Okay? So continuing. Oh, one other thing. A lot of people will start with this step right here. If you're going to do that, you need to be really careful because it's really easy to get these flipped around or whatever. So I always start with plugging in h comma k and then taking another line to plug in negative 15, negative 13 for x and y. So here you have negative 20 squared. That would be 400. That's positive 400 because it's the negative times negative. Plus 13 minus 8, which is negative 21 squared. I think I know what that is, but I'm double checking on my calculator. I don't want to mess it up. I was right, 441. And then the sum of them is 841. So r squared would be 841. And if you take the square root of 841, you will get 29. So if they were asking us for the radius, if there were an answer blank or a direction that said, what's the radius? The answer is 29. But really, do I need to square root it? I wanted to know what r squared is anyway. If you square root it to get to 29, you're going to plug that back in. You're going to end up squaring it to get the equation. So I already know what r squared is. You see what I'm saying? Here's r squared, and here's r squared. It's equal to 841. So I'm ready to rewrite this with 841 in for r squared. X minus 5 in parentheses squared plus y minus 8 in parentheses squared equals 841. This is the correct answer. There's what I just said. Okay, one more. says find the center and radius of the circle with the equation x plus 4 squared plus y minus 1 squared equals 25, and then graph the circle. So basically this is the opposite of a previous problem, where now they're giving us the equation, we're asked to find the center and radius, and once you have the center and radius, it's easy to go ahead and just graph it as well. Now I did put that one on my starboard here. So here's the equation, just copied over. We'll write the center and radius here, and then we'll graph the circle. So the center would be at, well, let me just pause for a second and see what you would say. We need to interpret this plus as minus negative, right? So because the natural state of the equation of a circle is minus here, when you see plus, you should interpret this as x minus negative 4. The center is actually negative 4, positive 1. Negative 4, 1. The radius is going to be the square root of 25, which would be 5. So negative 4, 1, and a radius of 5. And then with that information, like I said, we can go ahead and plot that. So negative 4, positive 1 would be here. Okay. And then for as far as getting the circle, that's the center, right? That's not really part of the circle, but we're going to measure from there the radius. As far as that goes, you really just need to go in 4 directions. Go up 5, down 5, left 5, and right 5, and then draw the circle. Now I'm using a old piece of equipment with a stylus that doesn't work very well, and you should at least be able to draw a circle as well as I can. So try to do your best, and it should look at least as good as that. I'm only kidding. But in truth, when you go to draw a circle, try to give it some circular, I don't know, tendencies. Try to make it look as much like a circle as you can. Something like that, right? Again, I freehanded that one. The last one was a joke, but that one I really did freehand. And you should be able to do it that well. What I'm saying is sometimes I'll get somebody who gives me basically this. He tries to tell me that's a circle. Okay, you knew that wasn't a circle when you were a couple of years old. So give me the blue one, please. All right, that's it. Thanks for watching.